Imagine a customer order enters your factory today. Do you know exactly where that material is right now? Which process it is stuck in? Or how long it will take to reach dispatch? Most organizations don't have this visibility. That's why we start with mapping material flow, the physical journey of the product. Now let's understand what material flow really means, in simple terms. Material flow is nothing but the actual movement of the product from raw material all the way to finished goods. And this journey includes everything, where the product is processed, where it moves, and even where it waits. Now this is important. Material flow is not just about processing. It actually includes processing time, waiting time, and transportation. So when we look at material flow, we are looking at the complete journey of the product. And here's the key insight. The customer only pays for value-added activities, but in reality, the product spends a lot of time in waiting and movement, which adds no value. So by understanding material flow clearly, we can start identifying where time is actually being spent, and where waste is hiding. Alright, now let's actually build a current state value stream map step by step, just like you would do in real life. Step 1. Start with the customer. Always begin from the right side with the customer icon. Here, we capture key demand information, monthly or daily demand product requirements. Delivery frequency. For example, if the customer needs 18,400 units, we convert that into daily demand. This is very important, because this demand will drive everything else in the map. Step 2. Map all process steps, bottom flow. Now we move to the bottom. This is where we draw material flow. Start from left to right and add all major processes. For example, stamping welding, station 1, welding, station 2, assembly, station 1, assembly, station 2, shipping. Each of these is represented using a process box. Step 3. Add data boxes below each process. Now this is the most critical part. Under each process, we add a data box. Here we capture real shop floor data like cycle time, CT, changeover time, CO, uptime, number of operators. This data should come from Gember observation, not assumptions. Because this is what makes your VSM accurate and useful. Step 4. Show inventory between processes. Between each process, add inventory triangles. Also mention number of pieces or days of inventory. This helps us visualize where material is waiting. And remember, where there is inventory, flow has stopped. Step 5. Draw material flow. Now connect all processes using arrows. This shows how the product moves from raw material to finished goods. Flow should be drawn from left to right. Material enters the system from the left-hand side in the form of sheet metal. It moves first to spot welding workstation 1 for the initial joining process. After spot welding, the material is transferred to sub-assembly workstation 2. At this stage, components are partially assembled into a subunit. Next, the material flows to assembly workstation 1. Here, the product takes a more complete shape through further assembly. From there, it moves to assembly workstation 2 for final assembly operations. Once assembly is completed, the product goes to the inspection stage. At inspection, quality checks are performed to ensure all requirements are met. Finally, the finished product is sent to shipping. From shipping, the product is delivered to the customer. At the other end of the map, we'll represent the steel supplier with another factory icon. We use the same truck icon and broad arrow to show movement of material from the supplier to Acme. The steel arrives as coiled steel and ships twice a week. We record in a data box that the supplier's pack size is a 500-foot roll of coiled steel. In other words, the supplier cannot deliver less than a full coil, but can deliver any number of full coils, as requested. Once at Acme, the coiled steel is taken to a storage area, as shown by the inventory triangle. Each of these spot welding and assembly workstations are separate processes. Because, as you can see in the overhead view of the plant, these workstations are not located next to each other. Products do not move in a continuous flow from one to the next. Instead, they are transported between the workstations. On the map, each of these processes is represented by a process box. These boxes are arranged from left to right along the bottom half of the page. Unlike the Acme stamping example, many value streams have multiple flows that merge. Draw such flows over one another, as shown here. But don't try to draw every branch if there are too many. Choose the key components first, and get to the others later, if needed.